The next part in lesson 10.3 is discussing odds. The odds of an event happening are different than the probability of an event happening. It says compare the likeliness of an event occurring to the likeliness that it doesn't occur, or vice versa. Now we're not looking for sample space. So we have two situations. Situation A, meaning an event can occur, and event B, where it won't occur. And we'll have to kind of figure those out depending on the given problem. We write odds in a couple of different ways. Fraction form would be A to B, or colon form would be A and then colon B. And we'll most often, well, we can kind of mix and match how we write our answers. It really doesn't matter. And the big thing, again, to remember is we don't use sample space for this type of problem. A card is drawn from a standard deck of 52 playing cards. Find the odds in favor of drawing a 10. So A is the in favor. So we have to think about how many 10s are there in a deck. There are 4 10s. But if that's what's in favor, then B, the opposite, would be not drawing a 10. So then we have to think about how many cards in the deck are not a 10. Well, if 4 cards are, then 48 aren't. And if we want the odds to be in favor, that means we want A colon B. So we want A to B for this one, which would be 4 to 48. And that reduces to 1 to 12. So to 12, not 11. So you want to consider it like in fraction form. You always want to simplify the odds if possible. Let's try the next one. Example B, against drawing a club. So now this time we're looking at B to A. We want B first. How many cards in the deck are against a club, so not getting a club? We've done this a few times already. There are 39 cards in the deck that aren't clubs. And then A would be how many ways we could actually get a club. And we know that there are 13 cards in the deck that hold true for that. Because we want against to be the forerunner in this, we'll do B to A this time, against drawing a club. That would mean it's 39 to 13. And that will reduce to 3 to 1. So we actually read that 3 to 1 odds. And I'm trying to make a quote over here, quotation mark. There we go. 3 to 1 odds. Over here, this would be 1 to 12 odds. That's how you kind of state that solution. All right, let's try C and D down below. Example C, in favor again. So in favor of drawing a heart. That would mean A goes first. How many hearts are there in a deck? So this is almost like the reverse of B, isn't it? How many hearts are there in a deck? There are 13. Versus how many ways that wouldn't occur, so not hearts. Again, there are 39. That would mean in favor we want A to go first, and that would give us 13 to 39 odds, or 1 to 3 odds. Less likely to get a heart at random if you're looking at odds. Now I'm actually going to change that last problem. Instead of saying drawing a queen, I'm going to say drawing a face card. Let's change that up and give it a little bit more to work with. So drawing a face card. Okay, so let's try that one. It says against drawing a face card. So now we've got to figure out how many cards in the deck are not face cards. If you count them up, there are 40 cards that aren't face cards. And then A would be the number of actual face cards. And that is 12. Since it's against, we're going to go B to A this time, just like we did up in example B up above. And that would mean it's 40 to 12 odds, and that reduces to 10 to 3. Your odds are better against drawing a face card than they would be for getting a face card. The last thing we're going to talk about in 10.3 is called experimental probability. So now you're not basing your probability of everything being equally likely. You're basing the probability on past occurrences of the event. So here's what I mean. If you play basketball and you shoot free throws, the percentage of time that you make a free throw would be the probability you'd make the next free throw. It isn't necessarily 50-50. Either you make it or you don't. So what experimental probability means, given a certain number of trials, like how many times you attempt something, The probability would be the number of times that your event occurs divided by the total number of times you've tried it. So it's almost like a sample space, but it isn't necessarily going to be that something's equally likely. For example, if you flip a coin 20 times and it lands on tails 14 of those 20 times, what is the experimental probability that it will land on tails again? So we'll do probability that it lands on tails. By definition, the number of times it occurred, which was 14, over the number of times that you flipped your coin, which was 20, the probability would be 7 over 10, and that's about 70%. That's pretty likely. But then if we compare that to theoretical probability, flipping a coin, you should have two options, heads or tails, and they should be equally likely by definition. So now if we think about the type of option we want, if we flip a coin and it lands on tails, our sample space, or it lands on either side, our sample space is 2, either heads or tails. Tails would be one option out of the 2 total options. So it's less likely using theoretical probability than it is using experimental. So that'll come into play when we're looking at examples that have different types of options for probability to happen. And this is lesson 10.3.